Okay, so here are the sieve numbers. Here's the percent passing. We're going to put these onto our plot. And number 4, we have 100% passing. So number 4, 100%, there's our point. Number 10, 91.9. 91.9 is approximately there. 20, 74.9, 20, 74.9, about right there. It's all approximate. 30, 65. Okay, here we've got 20 and 40. We don't have 30. So it's going to be in here someplace. And 65 is here. So we end up with that point. It's, like I say, it's approximate. 50, again, we have 40 and 60. We don't have 50. But it's going to be in between there. So that's 56.7. So that's going to be in here somewhere. So what do we get? Yeah, about right there. 100 is on the plot, and 35.3, like that. 140, it's also on the plot. Oops, that one's not there for some reason. Okay, let's put it in there right now. So that would be 140, 13.2 is approximately, well, pretty close to about there. And the last one, 200, 1.4, 200, 1.4, looks like that. Okay, this is one way that we classify the soil. Now there are different charts, so this is one chart. I should say it's one chart. And the way this works is, for this chart, this is gravel. So we've already determined that we have a gravel soil, then we use this chart. So, and this is the USCS, Unified Soil Classification System chart. We start here and we work to, we start at the left, we work to the right. And so once we have a gravel, then we determine how much fines we have, which will let us determine where we go with fines. Then we, if we're over here, the bottom, then we can take these paths, and then, we eventually get to a description at the end. Now, along the way, what we want to get, though, also is this. So the final answer are these two columns. This is when we have a sand, so we've determined we have a sand. This is when we have silt or clay. So this is fine grained soils. Coarse grained soils, sand. Coarse grained soils, gravel. So the first, to use this particular set of charts, first you have to determine where you're at, whether you have a fine grain or coarse grain. So it all depends on the way that it works, is that to have a fine grain soil, you have to have you have to have less than 50% passing the number 200. So, I'm sorry, you have to have a fine grain soil, you must have more than 50% passing the number 200 sieve. And so if you have that, then you are in the fine grain category. If you don't have that, then you are in the coarse grain, sand or gravel. So if you determine you have a coarse grain soil, then you just figure out, do I have more sand or more gravel? If I have more sand, then I'm in the sand chart. If I have more gravel, then I'm in the gravel chart. So it's all about figuring out whether or not you have sand, gravel, or a fine-grained soil to use this set of charts. If you have a fine-grained soil, then this chart will tell you where you are at based on the regions. These are the regions. And you plot, so you have 5 regions here, and you plot there's the last little region. You have the liquid limit, you have the plasticity index, so you take your liquid limit and plasticity index and plot it on this chart to see where you're at. And then also there are times when you need to plot the fine-grained portion of a coarse-grained soil. So in other words, if you have a sand that has a little bit of clay in it, sometimes you have to plot the clay portion of that sand on this plot. This is a blank plot you can use in the notes. Okay, so here's an exercise. What I want you to do then is you have these plots, these points here, and what I want you to do is list the grain size. How do you get that? You read down. So you have to read for this, you read the bottom x-axis. And I'll just say that to read that bottom, note it's a log plot. So everything goes up by a factor of 10 here. So, we have 1, 10, 100, 0.001, 0.01, 0.1. So everything goes up by a factor of 10. And notice that the small numbers are on the right, the big numbers are on the left. So a little bit tricky. It's worth it. What I want you to do is pause the video here and read these values. So I just want you to get used to reading this particular plot. Okay, so pause the video. Do this. All right, here's the solution. So point A reads down here. And what is it? Well, this is 1. And this is 10. So it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So notice they get closer. As we get closer to 10, the lines get closer and closer together. That's the way a log plot works. So if I read this, I got 1, 2, 3. So for point A, the grain size is 3 millimeters. For point B, it's what? Well, this is point 1, that's 1. So this is going to be point 1, point 2, point 3, point 4, point 5, point 6, point 7. So point B is 0.7 millimeters. Point D, this is 0.01. So 0.02, 0.03, 0.04, 0.05. is how you read that. Well, this is between, you can see it's between 0.01 and 0.02. So I read this is about approximately 0.014. It's approximate. Here's another exercise. Okay, so we're going to use curve 3 on this plot. So I'm looking at curve 3. That's this one right here. And I've drawn some lines there for you. And determine if the soil is well or poorly graded. Now in this plot, notice it's got the sand and gravel regions labeled as well as the silt and clay. How does that work? Well, the sand, this is the one you need to know. It's between the number 200 sieve, so the number 200 sieve is over here. The number 4 sieve is here. So the way to do this is, for any plot, is you draw the number 4 sieve, you draw the number 200 sieve, and that gives you the sand region. To the right is silt and clay. To the left is gravel. So it's pretty straightforward. So the way that it works is that we're using this curve. And so I bring a line down here. I bring a line down to the curve here. And then if I read the percentages off, this tells me the percent gravel. In this case, it's 25%. This tells me the percent sand. That region there. And that works out to be about 65%. And then below this are the fines, and it works out to be 10%. So what I want you to do is to determine what soil we have. Well, I'm helping you out with that. What do I have? I've got 65. Well, first, I don't have a fine-grained soil because that's less than 50%. So it's only 10%. So I don't have a fine, so I have a sand or a gravel. So now I compare sand and gravel. Well, what do I have? I've got 65% sand, 25% gravel, so I've got more sand than gravel, so I'm a sand. I've got a sand. So it's that straightforward to determine essentially the first part, the first letter of your soil type when you have a coarse grained soil. Now the rules, so we've established that. So I'm looking at curve 3, I've gone through that, and then the rules for sand, since I have a sand, are these. If the Cu is greater than 6 and the Cc is between 1 and 3, then it's well graded. If the Cu is less than 6, it's poorly graded. If Cu is greater than 6 and Cc is not between 1 and 3, then it's poorly graded. Now, what are the definitions of Cu and Cc? Well, Cu is d60 divided by d10. Just to remind you, Cc is d30 squared over d60 times d10. And remember the way that we get the d60, d10, d30. How do we do it? We look at the curve. Here's 60, I go over to the curve, down. Here's 30, I go over to the curve, down. D10, I go over to the curve, down. I read off the values of the grain size for those points. And that gives me the D60, D30, D10. So in other words, that grain size right there is D60 because I started out at 60. Here's 30, D30 is there. Read off the grain size. Here's 10, D10 is here. Read off the grain size. Okay, so do this exercise, pause the video here and do this one. Okay, well, this one we read off approximately 3 millimeters. This one we read off approximately 0.6 millimeters, and this one approximately 0.085 millimeters. And plugging those values into Cu, I get 35.3. For Cc, I get 1.41. And what do we find? That Cu is indeed greater than 6. And the Cc, what, is 1.41. It is between 1 and 3, so it qualifies as being well graded. So the soil is well graded. This is another, basically it's the same sort of chart. Again, well, if we're in the gravel, we have this one. This one's harder to read, obviously. If we have sand, we have this one. And then if we have to classify the the fines region of the coarse grained soils, we use this particular chart. So this is another chart that can be used for classifying coarse grained soils. Again, our goal is to get this letter and this name. Okay, so here's another one. Here's a curve, and find CU, CC, and type of gradation. In other words, poorly graded or well graded. And this again is the rule for sand. Find the percent gravel, percent sand, percent fine. So this time you have to do it yourself. Here's my gravel region to 4, here's my sand region to 200, and this is silt and clay. So pause the video here, find the percent gravel, percent sand, percent fines. Again, determine your CU, CC, which means what? I have to read D60, D30, and D10. Read those off. Okay, so pause the video here and do this exercise. Okay, well, so I mark off this region. That gives me this point here and this point here. So I have this point here and this point here. This is my gravel, 12%. This is my sand, 73%. The rest is my fines, 5%. So what do I have? Well, I have a sand, right? You can see it's pretty obvious I have mostly sand, so I have a sand. I read off my D60. I get 2 millimeters. My D30, I get 0.45 millimeters. My D10, I get 0.14 millimeters. Plug in the value for CU, I get 14.3. For CC, I get 0.723. And what do I find? My CU is bigger than 6, but my CC does not fit in this range. So it's not well graded, it's poorly graded. You can't tell just by looking at the curve. You have to do this calculation. In general, the way that it is, if they give you, for instance, a sketch like this and say, what kind of soil do we have? If it's flat slope, generally it can be well graded, but you have to do the numbers. If it's like that, then it's poorly graded. And if it looks like this, it's something we can call gap graded because we have this sort of stair step, which means what? I have, soil in that region, soil in that region. So we have sort of groups of soil rather than distribution. Or so when I say soil with this grain size, soil with that grain size, so rather than a distribution of them. This is another chart that can be used for the USCS system. Again, we start at the left side and we move to the right. And this one is, if you see this one, usually there's a misprint in it and cross off that little line there. But basically, again, I'm not going to go into the details, but this one has, but if you're given this chart, you sort of have to use it. And what I'm going to say is that the key with this one is that we have all of these notes here. So it's sort of easy to use, but you got all these notes. That makes it more complicated. And where are the notes? All of these little things you have to read here, which correspond in, for instance, this one says E, F, and G. So you have to go in here and you read E, F, and G. And and those notes will pertain to this soil type. So again, you move, the first thing that you have to do is determine, do I have a coarse grained or a fine grained soil, and then do I have a sand or a gravel, and then we have what we call clean gravels or gravels with fines. Yeah, so the term clean means not many fines. Clean gravel. Clean sand means that it doesn't have many fines, doesn't have much silt and clay in it. And so they've divided it up into whether or not we have, so clean gravels are less than 5% fines. Clean sands, again, less than 5% fines. And gravels with fines means we have more than 12% fines. Sands with fines, we have more than 12% fines. Now, what do we do when we're in between? That's where it gets to be, that's where we have to pay attention to these notes. In other words, between 5% and 12% fines. When we're in silt and clay, what separates everything, whether the liquid limit is greater than or less than 50. In other words, when we look at our chart, the liquid limit at 50, if the liquid limit is more than 50, we have high plasticity, MH, or high plasticity clay, CH. If we're less than 50, then we have low plasticity, ML, CL. So the 50 is what separates high plasticity from low plasticity. And so in this liquid limit less than 50, we have all L's. OL is organic. I don't really cover organic. It's CL, ML, I'll stick with that. Liquid limit greater than 50, I've got CH is MH, CH and MH. And so you can read these to determine exactly what we have in this, for this type of chart. So they may give this is the actual ASTM chart. So they may give you that and you have to interpret this chart here. That is how you do it. And all I can say is when you get to the very end here, you got to read these notes and they'll give you some refinement on what you're doing. But they both, put it this way, this chart will get you to the same place as this chart will, which will get you to the same place as these charts will. So I'm just showing you different versions of the same chart because you may be faced with reading these different charts. Okay. And I'll just note that, you know, the whole system is set up that if my curve goes here, well, there's no 10. The 10 doesn't exist, so D10 is undefined. If we have that situation where D10 is undefined, then you know what, we're not going to need to use the system is set up so that you don't need CU or CC. So don't worry about it if you can't come up with a D10. Okay, so for this soil, this is a typical type problem you might get asked in a different way that you should be able to get an answer to. So if the percent passing the number 4 is 70%, and the percent passing number 200 is 30%, and the liquid limit and the plasticity index are these, what kind of soil do we have? So pause the video and do this problem. Okay, so if I have 70% passing the number 4 and 30% passing the number 200, what do I have? I've got 40% sand, right? Because 70 minus 30 equals 40. So I have 40% sand, which means what? So again, this is just, I have 30% gravel. Why? Because That's 70%. 100 minus 70 is 30% gravel. And then 30% passes the number 200, which means that I have 30% fines. So if I only have 30% fines, that means I either have sand or gravel, because I have to have more than 50% passing the fines to be a fine-grained soil. So then I have a coarse-grained soil, so I either have sand or gravel. Well, I only have 30% gravel, but I have 40% sand, so I have more sand than gravel. I have a sand. So that means that the soil here is a sand. Since I have more than 12% fines, I have a clay or silt. In other words, an SC or an SM, because I have more than 12% fines. One way to determine that is by looking at this chart. This is the easy one. So what do I see? I have a sand, so I'm here, and then I have more than 12% fines, which means that I'm either going to have an SM or a C. Now I just have to figure out, do I have silt or clay in my fines portion? And I take these and I plot it, and I'm in the CL region, so 33 and 12. The easiest way is to, so 33, 12, where do I end up? Right there. And right there is in the CL region. So I have SC because it classifies as CL. Now, if you keep reading, it'll say with gravel, because so it'll be clay sand with gravel, because the gravel is greater than 15%. And if we look on that chart, it's note I. So it's one of the notes you have to read. Okay. All right, let's look at, there's another soil classification that I don't cover in class, but is eligible for being on the PE exam, is the AASHTO classification. Now, how does the AASHTO classification work? Well, you have this chart here. And again, we move from left to right. It's a little bit different. And basically, we don't necessarily go all the way to the end. We don't go all the way to the end. We may go and we may stop here. Okay? So what does that mean? You stop when your soil fits. So as soon as I get a soil that fits, I stop. Now here are the soil types. These are not, we do not use the G, S, M, and C system. We don't use that. This is the AASHTO system. So they have a completely different answer. Their answers are A1, A2. I never noticed there's no A3 here. A4, A5, A6, A7. That's their soil types. Now there's some subheadings. So we can have A1A, A1B. Oh, there's A3. Okay, I was going to say A3, A24, A25, A26, A27, A4, A5, A6, A75, A76. So that is your answer for AASHTO. Completely different from the USCS, from the Unified Soil Classification System. Okay, so what do? Well, you simply read, well, I read this. And if my soil passes, if my soil passes these, then I stop and there's my soil type. If it doesn't work, if this doesn't work, then I go to the next one and I see, does it fit there? If it does, and then these things down here, then I stop there, and this is what I have, A1B. So, and then I keep going. This is all set up such that it's only going to work once, and then you stop. So let's just take a look at what it says. So if I look closely at this, I can see that, what does this say? I look at my sieve analysis, percent passing. And for this one, it says, we're looking at the number 10 sieve. If 50% maximum passes the number 10 sieve, for instance, okay. Put it this way, to fit this soil, I can have no more than 50 passing the number 10 sieve. And to fit this soil, I also can have no more than 30% passing the number 40 sieve. And to fit this soil, I can also have no more than 15% passing the number 200 sieve. If that fits my soil, that's what I've got. And then I should say, and then the fraction passing the fines, I should have a plasticity index of no more than 6. Okay. Okay, so, and then, you just, let's pick a different soil here. If I have an A24, if I get all the way to here, then it says I can have, the maximum I can have passing the number 200 is 35. But then at the same time, the maximum liquid limit I can have is 40, and the maximum plasticity index I can have is 10. So I have to meet all of these criteria to be able to stop and say that I have an A24. If it doesn't meet that, then I have to go on to the next one. We also have this little note at the bottom here, and I'll explain that. That applies to when we get all the way to A7. If you make it all that way, you got to pay attention to this note at the bottom. And yeah. Let's go to the next one. Now, there's also something called the group index that works into this. And the group index, GI, uses this formula that looks complicated. It's really not at all complicated. It's quite simple. You just plug in. It's just a plug-in. Where F is the percent passing the number 200 sieve. Okay, it's easy enough to get. LL is the liquid limit. That's easy enough to get. PI is plasticity index. There it is. Plasticity index. So, easy to get this, and this is the this works for, well, it doesn't work for soils that are A26 or A27, where we have the partial group index, and that's just this. So little glitches in the in this method, but it's got to pay attention to the notes. So what I want you to do is do your best here to classify this particular soil. So what is this soil? Here are my sieves, 4, 10, 40, 200. Here are the percent passing for those. So I haven't plotted the curve. You just read off these values. and then you've got your liquid limit, plastic limit, and your plasticity index. So use this information and then this here and this chart to classify this soil. So pause the video here and classify this soil. Okay, so what are we going to do? Let's look at it. So we go one at a time. And so I'm going to start at the left side. I'm going to go to the right. So I'm going to stop and check this soil first. What does it say? It says passing the number 10, I can only have 50 maximum. Well, here's my number 10. I have 93.22, so that doesn't fit. I have to keep going. So I can't, I've got more than 50. So next, I go, so I'm going to this soil. It says 50 maximum passing the number 30. Or sorry, the number 40. 50 maximum passing the number 40. I've got 81 passing the number 40. Doesn't fit this one either, so I'm keep going. I go to this one. Passing the number 40, 51 minimum, okay? That fits because I've got 81, so it says minimum 51, so I have to have more than 51 or more. I've got 81, so that works. So I'm here, but the problem is now at number 200, it says 10 maximum. I can't have more than 10. I have 75 passing the number 200. Nope. So I don't fit any of those soils. I go to the next one. 35 maximum passing the number 200. Nope. I've got 75. Keep going. 35 maximum. Nope. Got 75. Nope. 35 maximum. Nope. 35 maximum. Nope. 36 minimum. Okay. Now what? In other words, I have to have at least 36, and I've got 75. So I can check this out. So now let's see what else is here. Well, it says the liquid limit, the maximum liquid limit is 40. Well, my liquid limit is 42, so I'm too high in the liquid limit. I have to keep going. So I go to the next one, 36 minimum for number 200. Yes, I'm okay with that. 41 minimum for the liquid limit. I've got 42. Yes, I'm okay with that. So far, this is looking pretty good. But then I come to the plasticity index as 10. Plasticity index, 10 maximum. Mine is greater than 10. It's 26, so no, it's not that one. So I keep going. 36 minimum. Yes, I'm okay with that. But liquid limit 40 maximum. No, I've got 42, so nope, doesn't work there. So I've got to keep going. 36 minimum. Yes. 41 minimum for the liquid limit. Yes, I have 42. 11 minimum for the plasticity index. Yes. I'm okay with my plasticity index. So I made it all the way to the end, but there's a little glitch here, and now I have either A75 or A76. How do I decide that? Well, then I have to read this little note at the bottom. And the note at the bottom says, plasticity index of A75 is equal to or less than, well, liquid limit minus 30. So I have to calculate out liquid limit minus 30. Okay, so what is liquid limit minus 30? My liquid limit is 42. My liquid limit minus 30 is 42 minus 30 is 12. So, okay, so I calculate that out. What is that? What do I have to do with that? And it says that the plasticity index is equal to or less than liquid limit minus 30. So my plasticity index is 26. My liquid limit minus 30 is 12. And is so is my And so the question becomes, is my plasticity index less than this 12? The answer is no. So that means I don't have the A75. That means I have the A76. So my soil is an A76 way over here at the end. So this example is meant to show you how you have to go through all the way to the very end here to do this. Okay, that's how you do the AASHTO. That's how you do the AASHTO work left to right on this chart. Pay attention to those notes. Okay, this is the USDA soil classification system. So again, could be on the PE exam. How do we do this one? It's pretty straightforward. We have the percent clay, percent sand, percent silt, and we put it into this chart. You can see these regions. Again, we don't use GSMC. We don't use this. They got their own system, so we're not going to use that for the USCS. That's the USCS only. Instead, what we're going to do is we're going to come up with names: clay, sandy clay, silty clay, clay loam, loam, silt loam. All of this that's your answers. So you plot your soil, percent clay, percent silt, percent sand. Here are the numbers. 0 to 100 for the percent clay, and 0 to 100 for the percent silt, and then 0 to 100 for the percent sand. You plot your point on this chart, and if you plot it, here you have loam. If you plot it over here, you have sandy clay loam. So, okay, that's how you use this particular chart. So here is a soil, certain percent clay, percent sand, percent silt. So I want you to use this chart and figure out what kind of soil you have. So here's the soil type. And I'll just note that soils with gravel, you got to adjust the percentages a little bit, because notice there's no gravel here. We got clay, silt, and sand. There's no gravel. Well, how do you deal with gravel? Well, we sort of take it out of the picture here, and the way that you do it is you revise your percentages, and you get rid of the gravel. So you have a denominator with 100 minus the percent gravel, and then you take your percent sand, silt, and clay to come up with the percentages for these. So we just sort of subtract off the gravel, if there's any gravel. In this particular case, there's no gravel here. Okay, so plot this point on this chart and determine what kind of soil it is. So pause the video here and plot the point. Okay, so where is it? It says 60% clay. So what do? I go up. There's 60% clay. So I'll put that there. Percent sand is 30%. 30% is here. Percent silt is 10%. 10% here. So where do we go? Well, we go right there. And we end up at that. We really only need 2 of these to get there, but you can see that where do we end up? We end up with clay. So we're in the clay region. So the type is clay. All right, I'm going to pause there.